So, hello and welcome to a new challenge, this time by BYROW. It's a super cool challenge. I think it's a little bit complicated, but only if you don't know what to do there. So, yeah, um, the structure is quite easily, so to understand it is quite easy. And there are currently three answers. One is by me, so I did this challenge before, and another is by Bo and by Dim, and also Dim has a video on his channel, which I will link in the video description. So let's jump right in. We have here a grid of numbers, and in this grid there are 281 prime numbers. So every number counts only one, so are they're unique prime numbers. And how do you find those numbers? In three ways. Three ways: horizontally, vertically, and diagonally, and both back and forth. So we need to search this direction, 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 we need to search diagonally this way, diagonally the other way around, and diagonally this way as well as the other way around. And also parts of those numbers. So if you make this a number, then we also need to search in, for example, here for the 13, which is obviously a prime number. So let's do this. I will use a let function, but I will do the parts separately. So first I hand over this array. Then I think I need the number of rows later often. So I have here or want to have this as separate arguments. RW, yeah, 7 rows. Also columns, CL, columns, CL should be also 7. Yes. So, and now, okay, yeah, I will just do it a little bit differently. Now I include here a lambda that can reverse strings of numbers. So a simple reverse lambda. So if I have here, for example, this number, that I make this 9991733. This is a simple mid lambda. So you have here mid, you have sequence, len. You start by here with the latest, step -1, concat only 1, and then you concat this later on. So here, and this we can now use here in our let function as a lambda. If we call this reverse is RV for reverse lambda A, and now put here everywhere an A in. We can now test this out. Simple number. No, that's the not so cool part. Every time I don't put all the brackets in, Excel assumes that this is an error and makes here an asterisk. I don't like this. I think this should do this differently, but yeah. So you see here the number is reversed, and we can now use this later on. I will first do the numbers by row, and therefore I will also use the BYROW function. BYROW array is A, function is concat, close the brackets, and I have my numbers in BYROW. Same could be done by column, and yeah, BR, BC, BYCOL a concat, not concat. And what I can now do there, I can stack everything together BR, BC, and then also the reverse versions of this. But I therefore have an error here because my RE lambda, so my reverse lambda, will only do this for one part because I don't have here a map function in. So I need here a map function as well. I can give here dA right through, so map dA, and then also have here the lambda A. And now, oh, I have erased BYCOL. What did I do? Oh, sorry. BC BYCOL A CONCAT, and I can now do here RVBC, and you will see it is then reversed. So this here is the reversed version of this one in the normal direction. So now I can stack everything together. BR, BC, and RV from BC, and RV from BR. Close all the brackets. I will now have here a split array with a few errors, but no problem. Structure, no problem. You can use here the TOCOL function because I want to have everything in a single column. And I can ignore the errors and the blanks. So 3 is the default I use there normally. And now we have at least 28 numbers, so 7 numbers times 4. So all their horizontal and vertical numbers. Now we do the diagonals. And for them, I use one of a function I like, and a function there which is not used that often, the MAKEARRAY function. So we have here 7 rows and 7 columns. We can later in the let function use the arguments we have there, lambda AB. First I will show you the structure. So, and now you see here, for example, for this diagonal here, so the middle diagonal in normal direction, there the column number is the same as the row number. So I can use here this MAKEARRAY function. This is a little bit smaller, MAKEARRAY, A equals B. And now I can use an if statement. If this is true, then give me those numbers, otherwise give me nothing. Close all the brackets, and if I now concat this, I will have here the diagonal number. And what we can now do, we can use here a map function to create also the other diagonals. So, because you see here, the distance is every time the same. So, yeah, how can I explain this? I don't know. You will see this. So map sequence 13 rows, or 7 times 2 minus 1. Start by minus 7, I think. No, minus 6. Lambda A. Oh no, I don't. Shouldn't name this A. S. And now if A equals B minus S, close all that stuff here, then you have your diagonals. That easily. So here, this is this diagonal, then we have here the diagonal, then this diagonal here, and so on until we are through this field and at this diagonal here. I will also include this in our let statement. So the O for diagonal 1 here, this is RW plus CL, not VLCL, minus R plus 1. Otherwise we don't have any errors here. This is A. And we can now also include here the O, and we can now use our reverse function. W, sorry. And we have here all our numbers with order horizontal, vertical, and one of those diagonals. Because, you know, we have also diagonals that way. And for this, you can see here that everywhere, no, I'll show this differently. Everywhere where you have this diagonal, the number is the same. Because if you add A and B, so the row number and the column number, you get the same number there. And we can use this for our for the creation of our diagonal values. So we can use this here, the whole thing, sorry. And we can now say if MAKEARRAY equals, for example, 8, to have here the diagonal. Then we want to have this number, otherwise we want to have 0. And there we get, not 0, sorry, nothing. There we get this number, then we concat everything, and we have now one of the diagonals. We now need again a sequence function. We want to have a sequence from up to 7 times 2 minus 1. Start by 2. Step doesn't matter. Lambda A, no S, sorry. And now A plus B should be equal to S. And we need to have a bracket here. Okay, something is wrong. But why? So here this is map sequence 30 rows, start from 2, lambda S. This should be S. Yeah, now we're talking 7 times 2 minus 1. And we now have our diagonals the other way. So here 9 7 7 9 7 1 7 3 3 9. Where is it? Is this in here? 9 7 7. Okay, I can't find it. Strange. Is it the same as before? No, it isn't. Sorry. It's 9 7 1 7. Or okay, never mind. I can't find it, but this should be all the numbers in here currently. I don't know. 3 19. Oh, it's the other way around. Sorry. So this will be the reverse version of this. So it's 3 3 7 1 7. So 337179. Oh yeah, sorry. Yeah, found it. So now I will also include this as the second diagonal in here. So here dt for diagonal 2 rw plus cl minus 1, start from 2 is okay. 7, 7. I will also include here r v and cl, rw and cl, sorry. Yeah, this is an argument. Now I will also include this here, the dt, and also the reverse version of this. Close all the brackets. We have a value error. First this one. Where is it? LF. Okay, and exclude this here. Show me dt. This should work. RV from dt should also work. Okay, where do we have this error? I see. Here I have too much argument. So now we have 80 numbers, and we search for 80 because we have 4 diagonals with 13 values and 4 horizontals and verticals with 7 values. So no, not 80 numbers. Am I wrong? So we have here this one and this one. These are 7 numbers. Then we have this one and this one, also 7. And then we have vertical. So 80 numbers, sorry. Okay, 80 numbers. We have created our numbers here. Now we have a small problem because in here there's not only this number, which is, I don't know if this is a prime number. There are also other numbers, 33, 31, 31, 7, and also here like 339 later on. So we need to split this number in separate numbers, and we need to do this for every one of those numbers. So yeah, this we will do now, but first I name this L for list of numbers and use here first the unique function to get there only the unique numbers, so we have 9 numbers less, so the calculation then will be a little bit faster. So now we need to split this number into separate arguments. If you use here also the mid function, you can do this quite easily. Sequence, what is the length of the number? Length of the number. So we have split this in separate numbers, but we now want to have an decreasing end, to call it that way, and therefore I've used here also a sequence function. Then from. So this is not the whole thing we need to do. So, and therefore you have here those numbers, but if we erase, for example, the first sequence function, you see here, this is what we want to have. So that we have to increasing numbers starting from the first number, but we then need to start from the from different numbers. So for example, then from the second number, from the third number, from the fourth number, fifth number, sixth number, seventh number. And we need to have this for every of those numbers. And you can do here something like easily map here the sequence function in 7 lambda a. You can't do this. It will lead to a calculation error. But if you know one beautiful function, the reduce function, then you can do this. So therefore I will use here reduce. I have also promised to do a video about reduce on my channel by the end of next week, so stay tuned. Lambda a, b, a. Then I will copy here this formula in. So I have here only nothing, and here an array up to 7 or up to the length of a number. I should use this length of this number. Then I copy here my split formula in, and instead of nothing here, I want to use here the sequence there, so b. And you see here, oh, I only get nines. And this is here when I have here the value 7 in, because this is the last value. And then if we now want to have all the values, I use here VSTACK, stack A, and I have here every number that is in this huge number. I now need to drop the first row because I need here a 0. Otherwise, if I would left this out, I would not start at the first one. So that's this one, not 0, drop one number. And then I can also use here unique to get only the unique values here. So, and therefore we have in this number 25 other numbers, unique numbers. So, sorry, I need this. And I will now do this for this list of numbers. But you see, I can again not use the map function. So I can again not use the map function, because if I bring everything in this formula here, so a is my argument. No, I need to name this differently. C. Then you see here I get a calculation error because of the common array of array problems. And to face this, I need to use also the reduce function here. So let's do this here directly. So reduce, start with initial value 0. My array will be my L, so my list of all those numbers. Lambda CD, output first C, and then copy this number in there, or this reduce function in there. Unique drop here, this should be the number, so this should be L, not L, D. This should be also D, this also. Close all the brackets, and you will now see I get a single number because this is the last value we have here. But if I now stack C and this whole array together, I then get every number, and we have here 1176. These are not all the unique numbers, so I need here to drop again the first row and also use here a sort. And so here you see we have a lot of ones, for example, and then also a unique function. This if you first sort an array and then make unique, this is niche faster. So yeah, and we now have 649 numbers that could be potentially an prime number. So I named this n because I now have all the numbers. And what I will now do, I will search here in my LAMBDA library for the unique number lambda, No, can I access this? Enable editing. Yeah. Oh, sorry, this is not mine. Lambda. This is mine. Crazy. So here, name manager, I think it's called isPrime, and it's based on an lambda from BYROW. Then back again here, I will now input this as an lambda IP in here. I will name this a little bit differently to have it shorter, and it searches or hands out if a number is a prime number. So, for example, if I search for IP4, the argument will be false because 4 isn't a prime number because it's divisible by 2, but IP3 is true because 3 isn't prime number. So then I will use here filter function, filter n, and now map n lambda a, use here the is prime number lambda here, and I have 278. Okay, there's some missing. I think I need to debug. But we are close, and I don't know where the error is. That's a problem. So there we would have potentially 281 numbers. Yeah, but we only have 3 numbers missing. So I made here a few experiments. I saw my error. It's a dumb error because I handed my filter function over these numbers, and these aren't numbers. These are numbers as text. Somewhere it has detected those numbers also, but not every number. So if I make this here a normal number with minus minus, then I get here 281. So there is a result we search for. Now I think I will sort this a little bit more beautiful. Sort by f, then of f. Now it's a little bit more beautifully sorted. And I will also do here haystack count and rows from f, and my sort by thing here. Close order, not haystack, VSTACK, sorry. So count 281. I think this function is a little bit shorter as the first one I did, because I used here in more extent my reverse function, my reverse lambda in my let function. But yeah, I think it was a quite funny challenge. Sorry, I think I will use here with n my minus minus. Yeah, so I have also those numbers as normal numbers. Sorry for that. So I think it was quite a funny challenge, a little bit longer than normal, but yeah, a little bit of mind training. So yeah, thank you for attention. If you want to give this challenge also a try, you will find the link to the LinkedIn post by Dim in the video description, and otherwise I wish you a beautiful day and I hope to see you in the next video. Bye.